I'm going to demonstrate the operation of the Hewlett-Packard 3335A synthesizer level generator. The unit I'm demonstrating here today is serial number 164 Alpha 02858, and this is the signal generator that I have for sale on eBay. When the signal generator synthesizer comes up, it comes up at 1 megahertz. And you can see on the display here we have a frequency annunciator, and then over here we have hertz, and we have a million of them up there on the display. It also comes up normally with this unlock annunciator, and that indicates that the crystal oven hasn't warmed up yet. Now in this case the crystal oven is warmed up, but in order for this this to function properly, there's a jumper that has to go on the back panel. This is according to the specifications for the equipment. And when I put that jumper on, the unlocked annunciator now goes away, and the synthesizer is locked to the 10 megahertz crystal in the crystal oven. We're not seeing anything on the display yet, and that's because when you turn the synthesizer on, it automatically goes to an amplitude of minus 86 dBm, and my scope won't detect that signal. It's too low for my scope, so I'm going to go to 0 dBm, and now as you can see we have a nice sine wave on the oscilloscope. So we're set up with the output, the 50 ohm output of the synthesizer going to a 50 ohm input on the oscilloscope. And when I measure the voltage into the oscilloscope at 50 ohms, I'll get the RMS reading, which is 224 volts, 224 millivolts approximately, which is what you would expect for 0 dBm into a 50 ohm output. So the output of the synthesizer is accurate to the amplitude setting. Now I can also go to the 75 ohm output. It's switchable here, and so let's switch to the 75 ohm output. I'm going to put a 75 ohm terminator. Here's my 75 ohm terminator. I'm going to put that on there, our coax cable, and then I'm going to change the display input to 1 megahertz. So now we have 75 ohm termination on a 1 megahertz input, and I'm going to set in 0 dBm on the synthesizer. I'll auto scale that so we can get a good reading of the RMS voltage for the 75 ohm output with 0 dBm entered. And here we make our measurement, and there we are with 277 millivolts, which is what you would expect for a 75 ohm signal at 0 dBm. So that just demonstrates the accuracy of the output. So you know whatever it is you're putting in power output, you're actually getting out of the synthesizer, which is important so that you can tell what you're working with. The other issue that I want to make clear is that this is a level generator. So over its frequency range, which is 200 hertz to 80 megahertz, this synthesizer maintains the same output level over the entire frequency range. Now that's important if you're going to be characterizing networks and you want to know the frequency response of your network. You'll have a good solid input signal which you know will be maintained over the frequency range at the same level, so you can see what you're network is doing with that signal. And on the display, on the synthesizer, I'm going to zoom in here to a manual input. Here's a manual input, and I can hit this button. It'll light the light indicating that we're in manual mode. And I have a knob here which allows me to change the frequency of the synthesizer. So let's back off here so we can see the display and the oscilloscope again. And I'm going to start with megahertz. I'll punch in 1 megahertz here. And there's our display. And you can see now that we have 2 boxes up, 2 boxes down. This is 277 millivolts RMS. On the display, I'm going to use these arrow buttons to move over to my manual control at the megahertz level. And now I can turn the frequency up to 2 megahertz or 4 megahertz. The scope starts losing sync. And I can go all the way up to 80 megahertz. And let's do an auto scale here. And we'll see that we're at 80 megahertz, and we have a nice sinusoid. Now, the thing to notice here is we're 2 boxes up, 2 boxes down, and that level, as we go to 40 megahertz or 16 megahertz, we're still 2 boxes up and 2 boxes down. The scope is syncing up nicely here. But over the frequency range, this level generator, this synthesizer, maintains the same output voltage level into 75 ohms at 0 dB over the entire frequency range. So I think that's an important factor for everybody to understand. I'm going to show you a little bit more about the function of the display. That was the manual mode. I'm going to get out of manual mode here, and I'm going to go back over to how the keypad functions. And the way the keypad functions is that if you're in frequency mode, then whatever you enter into the keypad will be a new frequency. And then over here you have a vertical set of buttons, and if you put in a number here on the keypad and you hit the megahertz button, you'll be entering megahertz into the synthesizer. If you hit the kilohertz button, your number will be interpreted as a kilohertz number, and if you hit the hertz number, it will be interpreted as a hertz number. And then you can also go to amplitude, and you can put in your desired power output. If you put in 1 here and then hit the negative dBm button, you'll get negative 1 dBm. And if you put in number and hit the plus dBm, you'll get 1, 2 dBm, you'll get 2. And that's the way that function works. So I think it's clear how you would use those. And then over here on the right hand side, finally we have some sweep control buttons, and you can enter a center sweep frequency. Whatever frequency is displaying on the display at any given time is your center frequency. So let's just put in maybe 5 megahertz, and we'll resync the display, resync the scope to that. So now we have 5 megahertz center frequency for our sweep frequency, and then I could put in a sweep width, and there's a button over here. Let's see if you can see it. It says sweep width. That's this button here, and I'm going to put in a sweep width of 1 megahertz. And I'm going to clear that entry, put in 1, Oh, wait a minute. Sweep 1, and I have to hit the megahertz button. Okay. So now we have a sweep width of 1 megahertz on a 5 megahertz center frequency. And I'm going to come back here and get us another good view. Seem to be okay. Let's get that accurate there. And so I'm going to demonstrate the sweep function. And you can see on the display we have sweep width set, and there it is, 1 megahertz. Over here there's a button that will give you the starting the starting sweep frequency. So we put in 1 megahertz, so we've got half a megahertz below that for starting the sweep, and then it'll go up to half a megahertz above that for a total sweep width of 1 megahertz. And we're going to go ahead and start the sweep, and you can see on the display that we are sweeping. It's going rather fast. I'm going to stop that. There is a 10-second sweep, and that's a little bit slower. You can see it moving back and forth, and you can see the display changing it, and I'll do that again. It starts at 4.5 megahertz and it goes up to 5.5 megahertz, and that's the sweep function. There's that was a 10-second sweep. There's also a 60-second sweep. I won't bother with that, but that function also works on the display. It's much slower. And I think that pretty much covers the functions of the synthesizer. It's a quality piece of equipment. It performs in accordance with the specification for the equipment. It's accurate, and it's a valuable piece of equipment for your lab, especially for characterizing networks. And I'll have it available on eBay.